Hi everyone, today I will explain you how can you create another code. In this example we will study together this example. So here is my sandbox. When you reach you click on the readme and you have my sandbox as you can see here, and you go down and this is some example, and in this video I will explain this example that I explained the previous Wednesday on this week. So we will disturb the interface locally by using a cosine function, and let's see how can we do it in Basilisk. So first, as I said previously, I need to include some libraries. So these libraries comes from, if I click here, the incompressible Navier-Stokes solver. So I need this solver to, of course, make some fluid mechanics simulation. So I need this one. Also, I will have two phases. One below will be the liquid and above will be the gas. So I need to include the two-phase flow solver. I will also use the reduced.h solver that allow me to include the gravity. And the same thing about tension.h. I will be able to include the surface tension. And finally, the last library that I use, it's just to visualize my simulation. So if I go back, here is the folder. So this file comes from the Professor Palas Kumar Farzoya. You can find his sandbox here. Just you click and you reach to his sandbox. And for us, we will start to explain the problem. So imagine a square and you have a border to separate two regimes. So one below you will have the liquid, and above you will have the gas, and between both you have the interface. So for example, here is you have the lower density, upper density, so that's meaning the water in our case and the air. And you have also surface tension and gravity. So this is a CGS units, centimeter, gram and second, as you can see here. And then I call the main function. Inside the main function, you will have some option. So first, you have the size of your square. Typically, when you do a simulation in Basilisk in 2D, you will have a square, and in 3D, you will have a cube. So this is a 2D simulation. So I just need to define one side of my square, and the side will be L. And the value of L is 10, of course. And then I define big N equal to 256. This is the mesh. In this simulation, it will be a uniform grid resolution. So this is the value of the grid. So ny times nx, and x times ny, sorry. Then I define the density, so rho 1 and rho 2. The same rule for the viscosities, dynamic viscosities, and surface tension. So this is a keyword for the surface tension, F dot sigma. That means you specify the surface tension at the interface. And then the gravity. So if you see, the gravity is a vector, and you need to specify the orientation of this vector, where you would like to impose the gravity. So of course at the y-axis, and you put a minus to have the downward gravity, sure. And this command is just a tool, that's meaning it will create automatically a folder. And then don't forget to include the run command to run your program. So here, that's it for the main function. Now we have to define the initial condition. To do that, we will call an event, a special event init, when t equal to 0. So this is some keyword you have to keep in your mind. The name of your event and when you would like the event appears. So at t equal to 0. At t equal to 0, I would like to define my interface, the initial shape of my interface. So this is the function, fraction function, which contains f. So f is the variable of your your interface, sorry, and then you have to you have to enter the equation of your interface. And here is the equation. So imagine you have a line with a cos, and it's locating at y equal of this. Like that, you have this equation, and you just have to put it inside after the comma. So f comma equation of your interface. That's it for the event init. And then, just to finish the code, here is a powerful function just to help you to visualize your data directly from Paraview by using VTK new cell. And then I add this one. It's just to check your interface. So that meaning f equal to 0.5. The volume fraction has two limits, so 0 and 1. And at the middle, it's the interface. And when it's finished, you just need to compile and run your code. Okay, so here is a Visual Studio Code. As you can see, here is the code. So it's exactly the same code that you saw previously, but directly on the VS Code. And to compile and execute directly, here is the syntax. So you have QCC, like that. You create an executable, you call your file .c, and you activate the mathematical libraries. And then if you use this command, you can just execute directly with one line. Or you can just put like that, you click enter, and then you just need to do that. So OSC like that, and you run your code. After simulation, you go to Paraview, as you can see here. You open your folder, and then you will find this square. So, as you can see, there is the liquid here below the interface and the gas above the interface. As you can see here, I can play the movie, for example, like that. So you see also an f, the lower limit of f is 0 and 1 for the max value, and at 0.5 it will be the interface. What we can observe in the code we saved, as you can see here, f, the volume fraction, the interface, u.x and u.y, that's meaning the velocity in the x-axis and y direction, x direction, y direction, and the pressure field. If you click here, you find what you saved, so f, p, and the velocity field. You can visualize also your mesh. Two options to do that. Surface with edges, as you can see here, or you can do that also. You click wireframe and you see also your mesh. So this is two ways to check your mesh. And as you can see, if I run the code, this is a constant grid, constant mesh. It's normal because I didn't use the adapt wavelet function. Alright, so I can check surface. For example, if I want to smooth the interface to don't see this diffusion, as you can see here, I just need to click and add some filter, and I will add cell data to point data filter. If I apply, here is the interface, as you can see here. So I have a kind of harmonic oscillator with some damping effect, of course. And to observe that, I can do it from Paraview. So, for example, if I zoom here and I put a square, for example, like that, I will use an option from Paraview. So this option is extract selection over time and then plot it. So I click here, I apply, like that. And as you can see here, at the right side, I have some graph. I have a graph, and I can plot a lot of information. For me, in our case, I will just plot uy, and as you can see here, you have this oscillation. You have many oscillation. Of course, the quality of this curve is not perfect because our mesh is very low, to 256. So we can increase more the resolution, but you can see the oscillation, harmonic oscillator. Yes, so here is what we can do. For example, in this example, we can observe a wave generating by the initial condition. So at t equal to 0, we define a cosine like that. Okay, and we just let the interface moves like that. So if I play the video and you see at the right, you have in information where are you at in the time. Right, so if you have some question or you didn't understand something, please send me a message, a comment directly on my YouTube channel. I will reply to you with pleasure, and see you in our next lecture on Wednesday. Bye bye.